Okay, just before we start this one, I just want to talk to you a wee bit about true length. When a line is sloping away from you, its true length is not seen in a drawing. Now I'm going to just try and illustrate that. If I put this set square down here, because you're viewing this from the side, you are viewing the true length of that edge there. If I turn that on its end, like that, you're now not viewing its true length. In fact, the length that you're seeing is the length of this side here, because the edge is sloping away from you. Now, this drawing is talking a lot about true lengths. It says you've got two scaled orthographic views, the elevation and end elevation of a lamp housing fitted to the wing of an armoured car. So this is a wee housing that would go on a lamp. Okay, so this could be plastic, probably would be plastic, and it's going into the end of the car, the wing of the car, and the wing of the car is sloping away. So it's going into there, and when you're viewing this end elevation, you're not actually seeing the true shape of it, because part of it is sloping away from you. Okay, or at least, sorry, that's incorrect. You are seeing the true shape of that, but you're not seeing the true shape of the opening, because it's actually sloping away from you. So there's a technique that we use to work out the true length of something, or the true shape of something, and that is to use two drawings, really, or two views. So in this case we're going to use the end elevation and we're going to use the elevation, and crucially what we're going to use on the elevation is really this length here, because we know that that length there is the true length of the opening. Okay, so you imagine in this lamp being pushed into a sloping wing. So how do we do it? Well, it's like any of these kind of drawings that you do. You have to use generators in order to produce it. Okay, so what we'll do is we'll start off by drawing generators on this here. Pretty much, you know, if you're kind of stuck on anything that's geometric and you've got a curved shape, start drawing in some generators and you're probably going to be on the right lines. Okay, and then from them we're going to project these points across until they hit the sloping side here. Okay, that one would line up with there. Now that's really only given us a couple of points, so we could bring in a 45 and introduce at least one more point. So I'm going to do that, and that will help when it comes to producing the shape up here. Now what we do is, you see how that centre line there is drawn at an angle, it's at 60 degrees. So I'm going to use this set square just to project some points. I'm going to project the top here up to there. Project this line all the way through, this line all the way through, this line all the way through, then the centre line, then the bottom here, okay, and that gives me enough points from here to translate onto information there. Now, the basic width of the opening is going to be the same as this here, so all I need to do there is just transfer information about the width from the centre. So measuring that, and then I can mark that on here, spin it round and mark it on there. Okay, now if you kind of visualise this for a minute, what's happening is this part this is the bottom, okay, I'm just tapping this in so we can see what I'm talking about. That's the bottom there. Then it slopes up, or doesn't slope up, it goes straight up actually to there. So it's on its side, there, and then there. And then what it does is it curves up to there and curves down to there. Okay. So to get information about heights, well, we've done that because we've projected them from here. To get information about the kind of horizontal points, I have to take it from here. So I'm going to project down from there, from there, from there. Okay. And then I take these points and I use my compass to mark them on this line here. Okay, so it's very similar to work that we've done before with isometric. So I'm going to measure and mark that point. Now it is symmetrical, so I'm just going to turn it around and mark the same point on the other side. Measure to that point, measure and mark. Then to this point, measure and mark. Okay, and then just project up from these points, and basically we're looking for where they coincide with the points on the slope here. Now I could do it with letters. Okay, I could do it with letters. I could go, right, we'll call this A, this B, this C and this D. In fact, that might be the sensible thing to do. So that makes that A, that makes that B, that C and that D. And then all you really need to do then is just go, right, there's D bouncing up to here. And where does it meet D here? Well, we'll just go up and mark a point there. Okay, where's C? There's C there, C is there, I'll just mark them here as well. C and D, so C goes up, it meets C here, like so. Where's B? There's B. Going up, across and along, and B meets up here. And then finally A goes up and joins there. And then just using the symmetry, you can work out where the other points go to as well. It's just like a mirror image across this line here. Yeah, that's us got all our points there. So it's just smooth curve time round about these points, and that'll finish off the true shape of the wing opening. So I'm just going to sketch these in just now. Just try and do them as carefully as you can. Okay, and then that's that completed. If you have any darting in to do the outlines, then just do it. And you can see that the true shape of the wing opening is very much like that. It just stretched, and that's exactly what it is. It's just stretched.